Hi everybody, my name is Ani. I'm one of your classmates for ERM Enterprise Risk Management, and I'm going to help you with risk financing simulation exercise 1, which utilizes this Excel spreadsheet, single risk auto liability. Now, it's going to be exactly like the practice exercise, except you're going to be doing it on your own with no instructions. But you can use the previous instructions to help you with this. As well as, if we look right here, um, we can see, yeah, I've got a lot of tabs open, but we can see this is the assignment that we're going to be completing. And it's going to be looking for it'll be looking at optimum efficiency, which is going to be asking, what is your retention? I would include what the retention is, how much coverage you're going to be getting based off your $50,000 budget, and just like a sentence saying, oh, we should be targeting the either best case, worst case, or mean scenario to ensure financial stability and achieve optimum hedging. That's what I would say for this one. For the second one, we're looking at what is the maximum risk reduction in risk. Uh, my dog is currently having a seizure. I'm just kidding. Um, so what is the maximum reduction in risk? So change in standard deviation. And basically, you would do let me just check real quick. You would do, basically, you would take, let me find it real here. To find your maximum reduction in risk, I listed out the best case, mean, and worst case, like the difference. But you're gonna be looking right here where it shows standard deviation. Let me move this up just a little bit. Where you see standard deviation right here, annual losses and net of risk transfer. You're gonna want to do this number minus this number. Pretty sure. Yeah, that's the one to answer the second question. And then the third question, what is the RF efficiency? Um, which is, yeah, what is the RF efficiency you were able to achieve given your budget constraint? Con Constraint, yeah. So right tail, left tail, and center. So looking at your right tail, left tail at center, you can see that this is the left tail. It's a very skewed left tail. The mean is bundled up right here, and your right tail, it's barely a right tail, but this is what they mean by the right tail. Oops, I moved that. Didn't mean to do that. So that's what they mean by your right tail. And I'll show you the practice exercise, the instructions. They show you how to calculate RF efficiency. It's actually not too bad, and I will be showing you that. So why don't we get started with just this page. The financing tool has been turned off, and we can see this is the original for auto liability risk probability. This is what it looks like without any risk retention plan. And the purpose of what Dr. Miller is basically this assignment is for is to see how much coverage can we get on a $50,000 budget while retaining the least amount of loss, but also making sure we cover these annual losses. So why don't we take a look at it? I'm going to turn this financing exercise on. You type a 1 in, and we don't need to really focus on the graph. Or actually, you see how this is the right tail? How it's a high probability for the most part on the right tail, but barely any losses. So what does that mean for us? Let's look at the annual loss for best case. We only need to look at 3 scenarios: best case, mean, and worst case. So best case, $22,000. $22,000 with a $50,000 budget. Why don't we retain 0? Based off what we did for practice exercise 1, we're going to do the exact same thing here. 0, and actually, yeah, we're going to use goal seek for this. Remember that we have to use goal seek to get as close or exactly $50,000. So let's use goal seek. We're going to change this to 50,000. I'm going to put a comma in there. We're going to change this cell. How much can we get for 50,000? And as you can see, we can get 50,022. So a little bit more, just a tiny bit more than the actual 50,000 budget. So, I mean, that's your correct answer for, what do you call this? The best case. So, yeah, that is the one of the solutions. But that's not what you're gonna type in your risk financing exercise assignment. That you're gonna have to figure out on your own. But based off what I told you, this is what you're looking for. Now, let's go ahead and do the mean case. Or actually, before we even do that, since they want us to know what is the change in uh change in standard deviation, that's one of the questions in your thing. We can actually look at that right here. Change in standard deviation. You can see how this number is not the same as this number. It's actually just a tiny bit different. So if we're looking at the change in standard deviation, that looks like it's 31, $31. No, this is not dollars, but it is 31. So that is not an answer you would put because it's looking for the maximum reduction, but it's one of the reductions out of the scenarios. This is one of the reductions. You yourself will have to figure out between the best case, mean, and worst case, what is the biggest difference between this number and this number. Okay? Okay, so why don't we move on to the mean scenario? So the mean scenario, if we were looking earlier, this is a little bit different because we chose 0, but this is the mean right here. So this this big bulge here is the mean. But in terms of the scenario, annual losses, it's 2 million. 2 million. So just like how we did in the practice workers' comp, how actually right here, the mean losses were 3.6 million, we're going to do the exact same for this auto liability, and we're going to type in 2 million. 2 million with a $50,000 budget, remember? And we're going to do a goal seek. How much for 50,000? Oops, that's 59. And we're going to change this. And it's going to come up with a number. Ooh, let me fix that. Hold on. I figured out the error, and you got to remember, everybody, that there is a negative sign in front of the retention number. That's a big part of the simulation. If you don't put a negative number, it will not work correctly. So just remember to put a negative sign, otherwise your goal seek won't work. So 2 million, just like how this was 2 million. Oh, we don't want to do that. This is just like how this is 2 million. We're going to make that 2 million. And we want to find the insurance limit of coverage, so we're going to use goal seek. I had a little like panic because it didn't work earlier, but now it works. So make sure to have that as a negative number. So 2 million, and we're going to set this value to 50,000 because that's our budget. And we're going to change the insurance limit of coverage. And boom, there you go. That's your number. That is, now you can come up with a different number if you want on your own. But this is how the practice exercise did it. And if you want to follow along and do that exactly the same way for this one, you can do that. But I would suggest playing around with it and making sure that you understand what's happening here. Because we used GoalSeek out of the 10,000 simulated years, it found that we can get, with a $50,000 budget, $128,000 of coverage, and this number plus this number is more than the mean of annual losses. Now, if you had changed, I'm doing this on the fly here, so let's see what happens. If you had maybe negative 1.5 million, right? And you wanted this number to be 50,000. me just make sure that I selected the right one. Cancel all that out. This number is 50,000. And we're going to change this one. You could see that we don't get enough coverage for the mean. You can see that this is 2 million, 2.01 million, and we're getting only about 1.6 million worth of coverage, technically, retention plus the coverage, and that's not enough. So you want to focus on this 2 million because that's how they did in the exercise, and if you retain the 2 million, then you're going to have just enough coverage to close the gap for the mean losses. Where this limit of coverage really comes into play is for the worst case scenario. So let me show you that. How in the this is the mean for the previous one. So in the risk exercise, they chose 2 standard deviations above the mean. So the mean here is 2 million, and you can see that this standard deviation is 1.21 million. That means 2 standard deviations of, oh, sorry, that is 1.41 million. 1421858 times 2 is about 2.84 million. 2.84 million plus, let's see, 2 million. Yeah, that's the mean. We could say that's about 4.84 million. But why don't we take a nice round number and retain about 5 million? Now, you might be asking, why did we choose 5 million? And I could show you. In the previous example, in the previous exercise, the practice exercise, they said it was an arbitrary number. But if I cancel this risk tool, we can look at the graph and see that the probability decreases, but the severity gets higher. And 5 million right here, it's still a pretty good probability that it could happen. But look at this whole rest of the thing. This is like the last major little bump in the chart, in the graph, that I think, me personally, we require coverage in. So everything to the left of this will be covered by insurance. And how much insurance do we need? If we're going to take an annual retention of 5 million, that means for a $12 million loss, we need around at least 7.35 million worth of coverage. Will we get that? We'll see. Now, using GoalSeek here, we can change this number to 50,000 because that's our budget. And remember, Dr. Miller said there's going to be quizzes on this, and see how quickly I'm going through this. If you understand the concept of you are trying to find enough coverage from retention and the insurance limit of coverage to equal or be better than these scenarios on a $50,000 budget, you'll be fine. And we're going to change this cell. So setting this cell right here to 50,000 by changing this variable. And you can see, oh, I see why. Yep, yeah, hold on. I didn't even turn the risk financing thing on. So you can see at 128,000, we only have $5,000 of the budget used. So we have so much more budget to use, about 45,000 more, and we're going to change this number, right? So, I'm sorry for the abrupt cutoff. My recording software apparently stopped. But we were looking at $5 million worth of coverage. Let me type that in. -5, remember, of retention, not coverage. And what does that mean? We are 5 million out of the 12.3 million there. We still need about 7.3 million. So why don't we type that in? 7.3 million. 7.3 let's make it 7.5. That's a nice figure. You want to make it as less complicated as possible. And you can see here, it's 47,567. That is not the full budget. So there's a way you can make goal seek a little bit confusing and not work. And it's actually happened a few times if you change the wrong variable. And most times you'll be changing the limit of coverage to find how much you can get on a $50,000 budget. But if I do this here, you'll see what happens. Let's change this to 50,000, and we want to change this covers 12.5. If we add these two numbers up, that covers 12.5 million, which is higher than the worst case scenario. So that would work. But if I were to change this to, let's say I wanted more coverage, I wanted more limits on a $50,000 budget, you'll see that it just keeps on searching. It keeps on searching through all 10,000 scenarios of years of data, and it'll never find a number. And if it does, it'll be way out of the range like this one. See, look at that. Negative 104 billion dollars worth of insurance cost. That's not feasible. You shouldn't be taking that. We have a $50,000 budget and we want to stick to that. So what do? You have to take goal seek and still change this to $50,000. We're not changing that, but you take a different variable and you change the retention, because the retention plus the limit of coverage will equal whatever you're trying to find. And you can see how it found it so quickly. We went from 5 million of retention to negative 4.942 million. Now, if you add those two numbers up, negative 4.9 million plus 7.5 million, what do you get? You get 12.44 million in terms of retention and coverage combined, which is still just over your worst case scenario. Now, there's different ways you can add up to 12.3 million here. As you can see, there's different ways to add up to this. If you wanted $6 million worth of retention, you can do that. If you wanted $7 million worth of retention, you could do that. Let's play around with that. Remember, let's say the firm wanted less retention for our company. Is it possible? Am I able to get higher limits with less retention? Let's find out. So let's say I change this to 3 million. I only want to take care of the first 3 million. What is 12.3 million minus 3 million? That's about 8.7 million, I believe. I can't do math. It's 9.3 million. So $9.3 million worth of coverage is what we need. So why don't we change that to 9.3? Can we do that on a $50,000 budget? Let's find out. 300. Oops, that's not the correct answer. Let's look at that. Is it possible? I mean, looking at that, look how much the cost of insurance is. That is way too high. What if I goal seek this? I change this to 50,000. And sometimes you have to just play around with it. What if I changed this variable? Will it work? I highly doubt it. Let's check it. It's going to take a while, and you're going to see $50,000. You only get $270,000 worth of coverage. That's not enough. That's not 12.3 million. So what if we cancel that and change a different one? Change this cell to 50,000 and change this one to whatever it could be. If you wanted 9.3 million, not 9.5, $9.3 million worth of limit coverage, you have to have an annual retention of almost 5 million. So if you want to, you could take this, and this will be one of your answers on the practice exercise. So why don't we pull up the practice exercise? Or not the practice, this exercise. Oh, I made that way too big. Let's make it smaller. So, what section of a risk distribution, right tail, center, or left tail, should be targeted to achieve optimum efficiency? This is your opinion. I would look at based off what we calculated for best case, mean, and worst case. I would put that in the box right here. Download it and type in the box your best case, your worst case, and your mean case. How much retention did you have? How much coverage did you have? So this retention, how much coverage did you get? And um yeah, that's what I would type for each one. Mean, best case, and worst case. And then at the end, I would put a sentence saying, based off what I calculated, we should be targeting either best case, worst case, or mean. And it's up to you to decide based off your calculations, remember. What this question is asking is what type of insurance or what kind of scenario should we focus our insurance efforts on? And it's just like the first practice exercise. The second question, what is the maximum reduction in risk? Remember, the reduction in risk is this number, the standard deviation, minus this one. See how there's a difference here? You do the subtraction, and you get a number. And that will be your reduction of risk. Where did that document go? Right here. That's your maximum reduction of risk. You're going to look at the best case, the mean case, and the worst case. And what I would do is just type them each case scenario out right here and type out what the difference was in the standard deviation. And the highest one, the highest difference, the biggest difference, is your answer. And now let's look at what is RF efficiency. What RF efficiency were you able to achieve given your budget constraint? So this is the formula that they give for uh, RF efficiency. So they say, let's zoom in a little, the risk minus the risk of the risk net of risk transfer. What does that mean? That means your normal standard deviation, the original one, minus the difference, or sorry, minus the net of risk right here. When you type in for a scenario, whichever one you're doing, that is the difference. You see this number? It's going to be different. You do this number minus that number. And in this scenario, that would be, so RF efficiency, let me make this smaller. RF efficiency, RF efficiency. I don't think that's how you spell it, but if that is, good job. RF efficiency is this number minus this number. So 1421858 minus 1268461. I could have typed that in Excel. I probably should have to make it faster, but that is 153397. That's your RF efficiency, the first part, divided by the expected cost divided by 1,000. Remember, your expected cost will always be 50,000 because that's your budget. So why don't we equals minus, no, divided by that and divided by 1,000. So that divided by 1,000. Hopefully order of operations does this correctly, but if it doesn't, we're going to add some parentheses. And you get this number. That is your RF efficiency for this one. And as it says, you need right tail, center, and left tail. And you do that for each one. Remember, it's this number minus this number. And it could be a different number for you. It's not going to be this number. But this number minus this one divided by 50,000 divided by 1,000. So 50,000 divided by 1,000 is 50. So this number minus this number divided by 50. And that's your R of efficiency for one of your tails. It just depends on which one you're doing right now. Whether it's right, which is your best case, your mean, which is your center, or your left tail, which is your worst case scenario. So I hope you appreciate, I hope this makes sense to you. I don't know what I was trying to say with the previous sentence, but I hope this makes sense to you. I really appreciate helping you guys out. and let me know if you have any questions. Um, this is the thing due on Wednesday, and we'll talk about it in class, I guess. I think that's what Dr. Miller said, but I'll see you guys on Wednesday. This will be a longer video, so I hope it comes out all right.